Okay, so in the previous class, we have been talking about statistics, and I did complete it. I did complete the major of central tendency. That is the prime major tendency, that is uh, mean. Along with that, I also covered along with that, I also covered variance and standard deviation. So that was the most important thing that was supposed to be done and that we have done already. So today we will cover the rest of the central tendencies like geometric mean, harmonic mean, median, and mode. And they are not really so important. Median is still up to some extent important. There are few formulas that you have to remember. That's it. Nothing much to do that. So measure of central tendency, we know that this is a tendency around which the entire data is revolving, which is lying in the center of the data. So about that, arithmetic mean we have covered. About that, arithmetic mean we have already covered. Now, this was that. That is sum of entire data divided by number of observations. All right. So today we will cover geometric mean first of all. Geometric mean is also a central tendency. So if x1, x2, x3 up to xn are n non-zero positive observations. If x1, x2, x3 up to xn are n non-zero positive observation. See, if I take an example, if observations are x1, x2, x3, then their geometric mean is x1 into x2 into x3 whole to the power 1 by 3. If I talk about x1, x2, x3, x4, then their geometric mean is x1 into x2 into x3 into x4 whole to the power 1 by 4. Similarly, if there are n observations, x1, x2, x3 up to xn, their geometric mean is x1 into x2 into x3 up to xn whole to the power 1 by n. So if we are required to take its log, it can also be written as this. Antilog is nothing but, like this can be written as e to the power 1 by 4 ln x1 plus ln x2 plus ln x3 plus ln x4. Am I clear? Now, if the corresponding frequencies of each observations are f1, f2, f3, in that case, geometric mean will be what? X1 to the power x, f1, x2 to the power f2, xn to the power fn, and whole to the power 1 by n, where n is what? Sum of all the frequencies. Got it? If you can remember these things with these two observations like x1, x2, x3 and x1, x2, x3, x4, that would be quite clear to you. Understood? Now let's come to harmonic mean. Harmonic mean of, again I will take an example for the observations x1, x2, x3. Harmonic mean will be 3 divided by 1 by x1 plus 1 by x2 plus 1 by x3. Got it? Now if there are 4 observations x1, x2, x3, x4, then harmonic mean will be 4 upon 1 by x1 plus 1 by x2 plus 1 by x3 plus 1 by x4. Understood? So similarly, if there are n observations, their harmonic mean is n divided by 1 by x1 plus 1 by x2 plus 1 by x3 and so on 1 upon xn. Understood? So similarly, if their frequencies of observation x1 is f1, frequency of f2 is of x2 and fn is of xn, then harmonic mean will be what? Harmonic mean will be n upon f1 by x1 plus f2 by x2 plus f3 upon x3 and so on fn upon xn. Got it? Where N is what? Sum of all frequencies. Am I clear? So with this two different, now these are two different new means, geometric mean and harmonic mean. Now let's come to median. Median is what? If x1, x2, x3 up to xn be n observations arranged in their ascending or descending order, arranged in their ascending or descending order, then if n is odd, median will be n by n plus 1 by 2th observation. Exactly central observation will be the median. And if n is even, the median will be n by 2th plus n by 2 plus 1th by 2. This number of observation. I'll take an example. Say there is the n observation. Say I take 5 observations. Observations are like 1, 2, 2, 3, 8. 1, 2, 2, 3, 8. Now they are arranged in their ascending order. Ascending order, then median will be what? Median will be exactly middle observation, this. So median is 2. Got it? Now let's take another example. If there are 6 observations, 1, 2, 2, 4, 7, 8. Again, they are in ascending order. They can be in the descending order also. That does not make any difference. Now in this case, median will be, now since there are 6 observations, so median will be what? Median will be the mean of these 2 central observations. Median will be the mean of these 2 central observations. It is 2 plus 4 by 2, that is 3. Understood? Now there is a formula for grouped data. If there is a group data, then there is a formula for this. Got it? I'll directly explain it taking an example. That will be the easiest one. First of all, take the formula. This is L. L is the lower limit of median class. There will be median class. I'll define it in a while. F is the frequency of the median class. H is the size of the median class. C is the cumulative frequency of the class preceding the median class. And then we place all the values and we get the median. Got it? Now let's take an example. The median of the following data is 525. They're asking for the median of the following data is 525. Find the values of x and y if total frequency is 100. Now see, they are saying total frequency is 100. That means sum of all these, sum of this entire frequency is 100. Now their sum will be 2 plus 5, 7, 12 and 7, 19, 19 and 17, 38, 48, 58, 58 and 9, 67, 67 and 4, 71, 71 and 7. Just a moment. 2 and 5, 7, 12 and 7, 19, 19 and 17, 19 and 17 is 36, 36 and 20, 56, 56 and 9, 56 and 9, 65, 65 plus 7, 72 and 4, 76. So it is 76 plus x plus y. So one relation you got, 76 plus x plus y is equals to 100. That means x plus y is what? 24. One relation I got. Now let us define a term, cumulative frequency. Cumulative frequency is what? Keep on adding. Iske respective it is 2. Now 5 plus 2, 7. Then it is add previous one 7 plus x. Then this is 19 plus x. Then this is 36 plus x. Then this is 56 plus x. Then this is 56 plus x plus y. 56 and 9. 65 plus x plus y. Add 7. It is 72 plus x plus y. And finally you add 4. You get 76 plus x plus y. Now they are saying median is what? Median is 525. Now median is 525. That means it lies in the class 500 to 600. Means this 525 is lying in this class. That means it is the median class. Understood? So 500 to 600 is the median class. Now let us define the values. See, L is what? Lower limit of the median class. So your L is what? 500. F is what? Frequency of the median class. Now frequency of the median class is what? 20. H is what? Size of the median class. H is what? 100. Now CF is what? C is the cumulative frequency of the class preceding the median class. So C is what? Cumulative frequency of the class preceding the median class, means cumulative frequency of this 17. So C is what? 36 plus X. Am I clear? Now we will apply the formula. Median is equals to L plus N by 2 minus C upon F into H. So that means 525 is equals to 500 plus 50 minus 36 minus X upon F. F is what? 20 into H is what? 100. Understood? Now if I simplify it, it will be 25 is equals to 14 minus X into 5. So 14 minus X is 5, then X is 9. 14 minus X is 5, then X is 9. I also have a relation X plus Y equals to 24. So while you got X as 9, Y will be what? 15. These are your values of X and Y. Just have a look at this question, absorb it. This is how we find the median for a group data, where class intervals are given with their respective frequencies. Understood? JNV Kolhapur, am I clear to you guys? Take a look quickly. Now, let's move forward. Now, mode. What is mode? Anybody? Now, first of all, very simply, before doing this, what is mode? Mode is the data which is occurring maximum number of times. Got it? Mode is the data. The mode is the value among the observations which occur most often. Mode is the data. Mode is the, or I should say value among the observations which is occurring maximum number of times. This is for a simple data. Understood? So this is for a simple data. Now, for example, if I take a very simple example, say this is number of wickets, and here it is number of matches. So like this is the data, like wickets taken by a bowler in 10 cricket matches are as follows. Got it? So wickets are 2, 6, 4, 5, 0, 2, 1, 3, 2, 3. So these are the wickets taken by a bowler in 10 cricket matches. Now, what is the mode? Mode, if you see, this 2 is occurring how many times? 1, 2, 3. This 2 is occurring 3 times. So this is the mode. This is not considered as a very good central tendency, but still we do it because it is being done. So 2 is occurring maximum number of times. So this is what? This is the mode of this data. Now, what do we do in grouped frequency distribution or in continuous frequency distribution? The interval which has maximum frequency is called model class. So first of all, what do we define? A model class. So the class which is having highest frequency is called model class. And in that case, formula for mod is this. Now L is what? Lower limit of the model class. F1 is what? Frequency of the model class. F0 is what? Frequency of the class preceding the model class. F2 is what? Frequency of the class succeeding the model class. And H is what? Class size. Got it? Let's take an example. A survey conducted on 20 households in a locality by a group of students resulted into the following frequency table for the number of family members in the household. So, first of all, family size 1 to 3, number of families 7, 3 to 5, number of families 8, 5 to 7, number of families 2, 7 to 9, number of families 2, 9 to 11, number of families 1. They are asking for mod of this data. Now, first of all, I will have to identify model class. Model class. So you realize that 3 to 5 class has frequency 8, which is maximum among all frequencies. So this 3 to 5 is the model class. Am I clear? Now let's see the values. L is what? Frequency of the lower frequency of the model class. So L is 3. H is what? Size of the class. So H is 2. Now, F1 is what? F1 is frequency of the model class 8. F0 is what? frequency of the class preceding the model class. So it is 7. F2 is what? Frequency of the class succeeding the model class, and that is 2. Now you have all the data. So mod is what? L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H. So L is what? L is 3, lower frequency of the model class. F1 is 8, F0 is 7 upon 2F1 16 minus F0 7 minus F2 2 into H is what? 2. So it is 3 plus 1 upon 7 into 9. 16 minus 9 is 7 into 2. So it is 3 plus 2 by 7. So that would be 7 3 are 21 plus 2. 23 upon 7. This is the mod of this grouped data. Got it? Have a look. Understood? Now, let's go forward. Measure of dispersion. Measure of dispersion. The measure of dispersion is designed to state the extent to which the individual observation vary from their average. Simple, see, there's a very simple theory. I also talked about it yesterday. Like there is a data 4, 5, 6, 7, 8. Its mean is going to be 6. There's another data 2, 4, 6, 8, and 10. If you calculate its mean, that is also 6. So mean of both the data is 6. But this will always be considered as a good data because it is not too much deviated from its mean. It is very less deviated. Second data is highly deviated, means the person who is having this kind of score is considered as unpredictable, whereas the person who is having previous score 4, 5, 6, 7, 8 is considered as a consistent performer because his values or his data is coming very close to the mean. So that is why we understand the dispersion. Dispersion means how much this data is dispersed from its central tendency. Now, the measure of dispersion is designed to state the extent to which the individual observation vary from their average. The commonly used measure of dispersions are first is range, then mean deviation, and then standard deviation. Understood? So first is range, then mean deviation, and then standard deviation. So data, if it is very much deviated from its mean, is not considered as a good data. And data which is very close to its mean is considered as good data. Now, what is range? Range is the difference between the maximum and minimum observation is called range. Now, definitely see in this data, range is going to be what? Range is 4. Whereas in this data, range is 8. And what I'm saying again and again, that the first data is a good data because it is less deviated. It will be having lesser range. So range is what? The difference between the maximum and the minimum observation is called range. So range is low, maximum value minus minimum value. L is the maximum observation, S is the minimum observation. There's a term also we should remember. Coefficient of range is what? L minus S upon L plus S. Coefficient of range is what? L minus S upon L plus S. Understood? Now, mean deviation, I have already explained you earlier. So, mean deviation is simply what? Subtract all the values from their mean, then take their modulus value and then take their average value. This is what we call mean deviation. Then this is nothing. Standard deviation also I have explained earlier, yesterday, day before yesterday class. Standard deviation is what? Under root of squares mean minus mean square. And one thing that you should remember, standard deviation is simple under root of mean of squares minus square of mean. Always it will work. Mean of squares minus square of mean. I have written also mean of squares minus square of mean. Variance is nothing but square of standard deviation. The square of standard deviation is called variance and it is denoted by sigma square. There is a term also called coefficient of variation. That is sigma upon mean into 100. Understood? Now there are few questions that yesterday I did this one. So today let's do few more questions. Got it? Let's start with this one. The mean and standard deviation of 20 observations are found to be 10 and 2 respectively. On rechecking, it was found that an observation by mistake was taken 8 instead of 12. Find the correct standard deviation. All right, so go for it. Yes, there you go. Briefly, I did this question also in the previous class. The mean and standard deviation of 20 observations are found to be 10 and 2 respectively. Okay, let me do it. Mean is what? Mean means X bar is what? 10 and standard deviation sigma is what? 2. Now that means sum of all the observations and number of observations is 20. Sum of all the observations is 200. Now see, on rechecking, it was found that an observation was by mistake was taken 8 instead of 12. An observation was taken 8 instead of 12. That means what? Sum of all the observation 200. So sum of the new observations, sum of all correct observations is 200. You took 8 instead of 12. So I subtracted 8, I added 12. So it became 204. So what is the new mean? New mean is what? 204 divided by 20. That is 10.2. Correct. Now, standard deviation was initially 10. So sigma xi square upon 20, mean of squares minus square of mean. Initial mean was 10. This is given as 2. So under root of this is given as 2. That means x1 square plus x2 square and so on, x20 square whole divided by 20 minus 100 is going to be 4. So x1 square plus x2 square up to x20 square is what? 104 into 20. 104 into 20. That is 2080. Am I correct? Now see, let us assume this is the observation which has been mistakenly written 8 instead of 12. So I will subtract minus 8 square and I will add 12 square. Got it? So now it became what? Sum of the squares of squares of new observations will be 2080 minus 64 plus 144. So that will be 2160. Correct? Now new standard deviation will be what? Under root 2160 divided by 20 minus new mean, that is 10.2 whole square, and it will come out to be under root of 3.96. This is how we do it. Got that? Here also I will do minus 8 square plus 12 square. Am I clear? Now let's do another question. Let ABC belongs to natural number and A is less than B less than C. Let the mean and the mean deviation about the mean and the variance of 5 observations 9, 25, A, B, C, B, 18, 4 and 136 upon 5 respectively. Then find this value 2A plus B minus C is equals to. Now see, on the one hand they have given A less than B less than C. Got it? So first of all, what is the mean? Mean will be 9 plus 25 plus A plus B plus C whole divided by 5. So, and this is given to me as 18. Mean is 18. So from there, I got A plus B plus C as 90 minus 25 and 9, 34. So this is what? A plus B plus C as 56. First condition. A plus B plus C as 56. Now, mean deviation about the mean is 4. That means magnitude of 18 minus 9 plus magnitude of 18 minus 25 plus magnitude of 18 minus A plus magnitude 18 minus B plus magnitude 18 minus C. And mod of all of them is what? So this is equals to 4. So that means magnitude of 18 minus A plus magnitude 18 minus B plus magnitude 18 minus C is 5 4 are 20, 20 minus 7 and 9, 16. So it goes 4. Second equation in ABC, we got this. Now let's come to standard deviation. So standard deviation is first of all directly this mean deviations square ka mean. So it is 18 minus 9 square, 18 minus 25 square, 18 minus a square, 18 minus b square, 18 minus c square whole divided by 5 and under root of this. This is what we call root mean square, RMS. And this is given to me as 136 upon 5. And they're providing variance. So this is under root of 136 upon 5. So we can directly remove under root if they're talking about the variance. Now this 5 cancel. So 18 minus 25 square plus, let's do it, 18 minus a square, 18 minus b square, 18 minus c square is 136 minus 81 and minus 49. So this comes out to be 6. So this is the third relation I have. 18 minus a square, 18 minus b square, 18 minus c whole square. This is the third relation that I have. Now, using all these values, I have to calculate A, B, and C. Now see, definitely 18 minus A can be 1, 18 minus B can be 1, and 18 minus C can be 2. So that their squares comes out to be 6 and their modulus values goes 4. So from this you get A as 17, B as 17, and C as 16. Now in the question, they are saying A greater than B greater than C. That means this 18 minus B has to be minus 1 and 18 minus C has to be minus 2. Understood? So with this data, we can say that this B will be 19 and this C will be 20. Now your all conditions are fulfilled and A less than B less than C also achieved. Got it? Now with this 2A plus B minus C they are asking. So that is 34 minus plus 19 minus 20. So your answer will be 33. Understood? So I assume I have made my point very clear. Got it? Now, the frequency, let's do another question. The frequency distribution of the age of students in a class of 40 is given below. So 15 is the age of 5 students, 16 is the age of 8 students, 17 is the age of 5 students, and so on and so forth. If the mean deviation about the median is 1.25, then 4x plus 5y is equals to. Give it a try quickly. Quickly try. Now see. Now, how many relations do I have? First of all, number of students. So 5 plus 8 plus 5 plus 12 plus x plus y. This value is total 40 students. So from this, I get x plus y as 10. So one relation is x and y. Now, if the mean deviation about the median is 1.25, Then 4x plus 5y they are asking. Now see, if I check for the cumulative frequencies, I'll make this table once again. Now, cumulative frequency 5, then 13, then 18, 18 and 20, 30, 30 plus x, and this is 30 plus x plus y, which is going to be 40. Now total 40, that means 20 mean of mean of mean of 20th mean of 20th and 21st observation is going to be median. See, 20th observation having age 18, 21st observation is also having age 18. So median is going to be 18. Now, mean deviation about median. What will be it? Sigma fi mod x bar minus m upon 40. That is total number of students. So 1.25 is given to you as C, frequency 5, and this will be 18 minus 15 mod. Frequency 8, this is 16 minus 18 mod. Frequency 5, this is 17 minus 18 mod. Frequency 12, that is 18 minus 18 mod. Frequency x, that is 19 minus 18 mod. And frequency y, that is 20 minus 18 mod, whole divided by 40. Now this is what? 18 minus 15, 3 5s are 15, 8 to the 16, this will be 5, then 0, then 19 minus 18 means x, and then 2y, whole divided by 40. This is what I got. That means 15 and 5, 20, and 6, 16. 36 plus x plus 2y is 1.25 into 40. That is going to be 50. So from there, I got x plus 2y as 50 minus 36, 14. Another relation, I got x plus y as 10. So if I simplify both of them, I get x as 6 and y as 4. Got it? X 6, y 4. So they are asking for 4x plus 5y. So 4x plus 5y is 4 6 are 24, 5 4s are 20. That is 44 is your answer. There it is. Understood? Have a look at this question. This question was in JEE Mains this year only. And this was an easy question. Moreover, same type of repeated concepts are coming over again and again. Mark my words, this is an easy chapter. you get a question from this, either in your school exam or in your JEE exam, you are going to crack it. It is very easy. Got it? So make sure you attempt it. And in a very simple way, you do it. Now, practice more and more from this chapter. This is going to be an asset for you. All right. Thank you so much. Now, I would like to ask for a small feedback from this class.